Hello everyone and welcome to yet another video in the Text-to-SQL project. This is an ongoing playlist, so I encourage you to check out the previous videos where we have iteratively built from version v1 to v5. In the previous video, we discussed or rather built test questions and ground truth data sets, and we also explored how we can use LangSmith as a tool to evaluate or run these evaluations and experiments. In this video, we'll build the version v6, which will include a new node that would validate the SQL query that's being generated. But before that, I wanted to quickly go to LangSmith and discuss a mistake that we made in the previous video. Now for the evaluator, I went ahead and I used a default code checker, which was an LLM as a judge. Here the input that we used was the input question and the ground truth answer. Now we made a couple of mistakes here. The first being these were the only two inputs. So what this is basically doing is, for the given question, it is checking if the answer is accurate and it's doing a code check on it, right? But what we want the evaluator to do is, for a given question, we want the output to be validated against the reference output, but we haven't passed the output to this evaluator metric. So what we were evaluating was not right. Second thing being, this is more of a generic code checker. It checks for the sort of quality of the code, accuracy, edge cases, and so on. These are something that we don't want. We want to specifically we want this evaluator to act as a SQL code checker. We don't want it to do a generic check on it. We rather want it to be more specific, where the output has to be validated against the reference output for any given question. So what I did was, I deleted the evaluator, added a new one, basically the same default, but I wrote custom system and human prompts here. As you can see, I have passed in three inputs here: the input question, the reference ground truth, and the answer from the model. So what this effectively does is, it's going to check the sort of accuracy of the two piece of code. Now of course it can have different alias names, maybe different ordering of the columns, different joins, maybe table A being joined on B or B joined on A. But what it is effectively going to do is to ensure that irrespective of these orders or sequences, it should give the same answer, right? So we're just going to look at and identify if there is any logical meaningful differences. If not, it's going to pass it off as an accurate answer. So that basically was it. And of course I ran the experiment on the Text-to-SQL like we did earlier, and this was the evaluation run. We can go into this detail, but for time being, this is the mistake that I wanted to highlight. Now of course in the previous video, the main point of discussion was the ground truth data sets and how it is important and how we can use it further moving on. But given its importance, it is necessary to set the right evaluator and the examples for us to move forward. With that, let's go to version v6. Here I've introduced the SQL Validator node. Now sure, this is generating the SQL code, but we want to ensure certain rules on it, right? And ensure that this SQL generated from this node is ready to be executed into a SQL engine. So what I mean by that is, we want the SQL code to be free from any sort of symbols, parentheses, and unnecessary words either before or after the actual SQL code. And we want it to avoid using aliases that's reserved for SQL functions. Maybe we don't want it to use certain joins. By default we want it to use inner joins, left join, so that it preserves all the rows. And there are, of course, certain rules that we can implement here, right? Maybe it could be in terms of styling, and so on. And of course, this is something that we can also pass it on to this specific node. But from previous videos, one thing that we noted was that when a lot of instruction is passed on to a single node, it starts to hallucinate. It already takes in the user query, table mappings, column selections, filtered knowledge base. So that's a lot of context already for it to generate a single piece of logical SQL query. It can miss out on certain things even if we instruct it specifically. So to avoid that, we have moved it to a separate node. So what this does is takes in the SQL query from the previous node, the original user query, and does a certain validation step. We'll go and look at what exactly they are. It outputs the validated SQL query, and it also outputs a validation reasoning stating what kind of changes it had made to this. With that, let's go into VS Code. So we have the version V6 here, and I have introduced two variables, state variables, to capture the necessary details. One is the validated SQL, and the next is validation reasoning, both being string. Let's come towards the end. Here, of course, we have added the node and the edge. This is a sequential flow. So from SQL generator, it passes on to the SQL validator, and from there to end. And this is compiled. Now, in terms of prompt definition, this is the same as the previous prompts that we have defined. You can take a look at it. I'll link the GitHub repo in the description. So we have followed the same set of system and human prompt structure. And some of the core responsibilities are identified or listed here, which I discussed sometime earlier. Some certain examples that it has to follow, like the output format it has to follow, and certain examples for it for its reference, and of course the input. In the output, we have the validated SQL and reasoning that's updated to the state. Right. I think also one more thing that I wanted to highlight is in terms of CTs. If it has complex subqueries, it will default or rather rewrite it to CTs. So yeah, so these are some things that we have done here. What more we can do is include some sort of styling choices, right? Maybe we wanted to have implicit aliasing without using AS, or maybe we wanted to use certain alias names, right? For customers, maybe we wanted to default to CUS, for orders ORD, for example, and so on. Also, maybe we want the SQL code to be in lowercase and the functions to be in uppercase, and so on. Now these are something that I'm not bothered with at this point, because ultimately this code will go into the SQL engine and query against the database. So I'm not really worried about these styling choices, but this is just to show why we need an extra SQL validator, where we can specifically instruct it to do all of these steps. So now coming back here, now again I have updated the state variables. This is something that comes from the previous steps as well. It wasn't there earlier, but of course now that we have updated the validator, these are two variables that gets passed on from the beginning. So with the SQL generator step, it basically validates this original SQL and gets updated here. In this step, I don't think I've added anything. Maybe one thing that I can add here is to specifically use an order by. So one more instruction that I passed on here was to use an order by if it makes sense here. I think this question is to find some order details. I can't remember what it was, but maybe let's say we want to order it by average review score. It may not be the accurate one here, but just to show it as an example. So this is the kind of validation it has performed from the original SQL query, and of course it also has a validation reasoning that gets updated on here. Right. Yeah, so these are two validation steps. Now going back to Langsmith, let's see how this run looks like exactly. Let's see if I have any example to show. Right, so let's look at this example. Of course, we had the other nodes earlier. Now we have this new node. If you look at this specifically, it takes in okay, this is the bigger one. Yeah, this should be concise. So it takes in the user query and the SQL query generated from the previous step, and here it sort of validates it and makes certain changes if required, and there is a validation reasoning. So these are the two state updates that it does. Now looking at the experiments that we can run to ensure that the whole v6 is actually an improvement, or at the or in the worst case at least doing this, performing the same as version v5. If you look at experiments, text to SQL, and the experiments, this was v5 and this is v6. This is something that I've run already. In v5, these were the sort of average scores. I'm not really bothered with these scores at the moment, because this can be more in the next run, this can fall down in the next run, because there is of course a bunch of other steps that's happening beyond just validation, right? But the point here is this should not fall way below the previous step. That's the main idea behind having a set of test data and building the what do you call, like a ground truth data set that we built, right? So yeah. Now one thing that I wanted to show here is if we group by the category, and the version v5 failed mostly in the joins and the complex logic ones. The others seem okay. If you look at the outcome from one of the runs, we can see how the model generated one has a join that is not inner join, so not the accurate join. Here in this case it has also left out another column or another table, but yeah, that's not the motive of the validator step. What this will do is it has to identify these specific joins or alias options and has to improve it. So this was in v5. If we come to v6, and let's group by, it has largely done well across all of the other questions. Still sort of struggling with complex logic. I'll come to that. But speaking of multiple, okay, we do have a mistake here. But looking at the specific join instructions that we have passed on, as you can see, in the reference it has left join, and in the final validation step 2 it has accurately picked up left joins. And if we look at the actual run from this, right, let's see, this must be the example, right? If you can see here, the input or the SQL generated from the previous step had a regular join, but in the final validator node it has modified it to left joins. Now of course we have limited examples here, so we might not be able to capture all the examples that we intended the validator to do, but nonetheless we can see why or how or basically discuss the highlights the importance of having a validator node, right? Yeah, so that's pretty much it for this version. One more thing that I wanted to discuss was in terms of modifying the piece of code for running the tests. So earlier in v5 I had a piece of code to test it locally, to check the specific outputs from the response, and one piece of code that would be used for Langsmith evaluations. But in v6 what I did was to have one single wrapper function that takes in the initial state, invokes it, and outputs two things. One is the whole response, and the other is a specific response which is like a key pair value, the column heading being answer, and the value pair being the validated SQL. I'll tell you how both of this is useful. What I did was I made a test eval notebook file. It basically imports this function from the specific project we're working with. So let's say if I want to test v6, so I import it from this Python file for local testing and one for Langsmith evaluation. For Langsmith, I basically have to put in the dataset name, link it to the client, and specify the function name. It will work with this dataset, pick in each question and evaluate based on the metrics and the evaluators attached. That works straightforward. But for local testing, we want to have the flexibility of being able to assess any of the state variables. We don't want this particular what do you call the particular key value pair, right? So that's why I have introduced a debug variable. By default, it's false. So by default, it will print this, which can be used directly for Langsmith. But if I were to do a local testing on it, I'll have to pass in the debug being true here. I'll pass in the specific query also, question that I want to validate, and invoke this. And finally, from the result point of view, I can try and assess any of these variables. So that's the kind of change that I've done to this test eval file. So moving forward, all we have to do is change the variable name or change the version name that I'm working with, and run the two tests depending on what I want to do. So that's pretty much for the video. What we discussed was the addition of the SQL Validator step and its potential use cases in this workflow. In the next video, we'll go and work with the other improvement steps. And yeah, thanks for watching, and hope you have gained something knowledgeable from this video. Thanks again.